Okay, so welcome back to the AI class. What we have seen last time was that we went through search algorithms, gaming, and we were especially going through the example of a min-max algorithm. Is that clear for you? Online?
Yeah, it made sense to me.
Yeah, okay. So actually what we did last time is that we were understanding the overall algorithm, how it works, but we were stopping so at the point where we tried to write the algorithm. So I don't want to miss any parts, even that I'm sure things are clear, but let's revise it together thanks to this formulation. So the min-max algorithm, first we are going to implement, we said, two functions. First, the max value function that is going to check if a given value is the maximum, because we want to maximize at some point. And in the other hand, we want to minimize. So let's start with the max value function, which takes a state as input and checks. If that state is terminal state, then it's all set. So it's going to return the utility value of that state. Otherwise, we are going to check or look for the max value. If we want to look for the max, and we are going to compare that with given values. So we start with the minimum possible value. So we go to up to minus infinity. We try to initialize a variable named v here and give it, let me say, minus infinity value means, let's say, for example, minus 1,000, minus 10,000, like that. And while comparing with such value, we can check if the current value is a maximum or not. Okay, so it's all about comparing. And here we are going to go through a for loop. And for each action now that belongs to the actions, we are going to check this value v is going to give the result of checking the max between this v, which is basically or initially initialized to a very, let me say, negative value, and then that is going to be compared to the mean value. Okay, so the concept is simple, and we are going to return in all cases the value of that variable v. The same concept applies for the mean value, where we are going to initialize this value v in a positive up to infinity positive value, and we are going to compare within the for loop in order to get the mean value and return that value. Okay, as simple as this. So now we were saying last time that the min-max algorithm has its own positive strength point and also drawbacks. One of them is the complexity in terms of time and space, and I think we were discussing this. And given the example of the game that we went through last time, the tic-tac-toe case, so in this case, the number or the complexity of this game goes up to 255,168, which is a huge number as compared to the tic-tac-toe space, which is, let's say, small. Yeah. So if we go to for studying the case of a more complex game, such as chess game, here we find that the number is completely huge, and we cannot even compare it to the tic-tac-toe game. So in this case, what we can conclude is that we can check or opt for a variant of this min-max algorithm. Like I was saying last time, each algorithm is coming up with the idea, like we see, for example, the A*, and then we say, scientists or people or students, or we can come up with suggestions. We say, oh, this is the worst thing in this algorithm. Let's try to fix it. Fixing that will not for sure give the best or optimal solution, but at least it's going to limit the cost. Okay, so what we can do in this case in order to reduce this complexity, which is in the order of O of b power n, we can whether go for cutting branches, means at some point I'm not going to explore all the branches. And as you've seen in the algorithm, there is a for loop. So this is taking the cost. So, or we can think of depth, because at some point, if I keep going, and you guys remember the DFS algorithm, So at some point, if I keep going in depth, that can make a problem. So this is another option. In case we are going like to go through the depth reduction. So we went through these examples last time in order to understand. So we were thinking like, what is the minimum value? Okay, the arrows at the up wants to maximize and the opposite direction to minimize. So here we are in the case of mean. So what is the mean here? I can select 3, right? And in this case, what I know is that my algorithm is going, if I am playing like min max, so the value that is going to be max here, it could be minimum 3. That is a fact, okay? So if I will be going further here, for example, between these values, I don't need to explore the rest. I see first values equal to 2, and I know that 2 is already less than 3. So here, without even checking the remainder of these like branch, I can understand that whatever the value, I don't care if it's 0, 1, or equal to 2, it would be at least like, yeah. So what we did is that we are excluding these nodes, and if we are excluding them, you can imagine if these are going more in depth, means everything else is excluded. Okay, so if in the start I already know that the value, if I'm trying to maximize and I have a 3, having a value which is less than 2, would it matter? No. So here I can even exclude it from this point. Okay, so this is the concept. And here, if we can consider these 2 elements or 3 elements, 14, 5, or 2, I know that the mean here is 2, and then even if I'm exploring, it's the same like concept. So this is the idea that is going to take us to this variant of the min max algorithm, which is the alpha beta pruning. And the idea here, if I am going in depth until, for example, I have my value alpha for max, for example, and the mean v, I can cut some like branches because I know that it's useless to explore that. So this is the same for the mean. This is the same for the max. It's always the same concept that applies. And the idea is just to cut branches. And we went also, I think, through this example. Okay, then. So we have it's the same example, 3, 12, and 8. I'm going to get the mean, which is 3. 2, 7, and 9. What I know here is that the mean is at least, yeah.
Should be at least either equal to 3 or it should be.
I want to minimize. So I have a value which is at least equal to 2 or more. Yeah. And then 1, 5, or 14. So I have a value which is
1.
at least.
At least 1.
Yeah. If I am going to minimize, so I will take 1 or more. So the idea, if here I want to maximize, then I would not consider these 2 branches because they are less than the value that I'm finding at some point. Here is in the start, and I will consider the 3. Okay. So here I just want to draw your attention because I know that things are clear, but at some slides, try to focus with what is mentioned here. Sorry. Here, for example, we say that the right child is added to the frontier first. For example, in the homework for the DFS, some students want, I would just try to clarify things here because I believe this is the best context to talk about this. So if I have a tree, and we know that, for example, most of the time we use whether the LIFO or the FIFO concept. So in this case, I want to go in depth. And if we consider this stack, the last in, first out, some students went through exploring this branch, which is not wrong. If they mention that the order, this is the last one that we are exploring, sorry. But what I did in the slides, if you didn't pay attention, I always mention, just to make it like agree, like let's agree, let's make a deal, that always we will consider that this is the last things added to we will always start with this side. So this is why in the correction that I'm going to upload tomorrow, we will find that this way of navigating into the space. So in this case, also, whenever you are having in the exam or some like homework, even if you are applying that concept, it's not wrong. Just you need to mention that in my case, I am considering the left side, which is added last, or the right side, which is added last, okay? If by default, I would consider that we are like following the course and we are adding the right side first, okay? So now we are done with this. It's again the same concept that we are going each time to eliminate some elements. And here we are like dealing with some like consequences of the min-max algorithm. So there is improvements in terms of complexity time because we are like not visiting every node and we are like going through some optimization like process. So what will happen here is that this is not enough because again, even if like every solution that could be proposed, there can be someone who say we can have better than this. So another amelioration of the min-max algorithm is to think of the DFS in this concept. When I say DFS, I just talk about the depth element, okay? And we consider that imagine the min-max algo, I don't completely like eliminate some path, but I let's make a deal. I am going to go in depth, for example, 10 or 12 or 15 like layers, and I'm not going to go further, okay? So we make a deal about the depth from the start, and that is going to make it like better at some points. Also here, it can take you to the more realistic case. For example, we are playing the chess game, and for example, you are not winning or losing. Still, the game is like, we are still playing. It's not complete. So in this case, what we can do is we can say that to evaluate as a function. So we use an evaluation function, which is going to tell you, okay, no one is winning at this point, no one is losing at this point, but let's say you are with the probability of 0.9 going to win. So here, once we are having an evaluation function, we can interpret or understand, or let me say, estimate the expected utility of the game at a given state. Is that clear? So here we are done with this set of search algorithms. And I don't know if any of you is having any questions?
I have a question.
Yeah.
So I was wondering, with that previous search you just mentioned, is it going to be a different, the evaluation function, is it going to be a different value depending on what the player is? Like the winner will have a different utility than the loser, for instance.
Yes, this evaluation function, it's a variant of, let's start. So we have the min-max algorithm. The alpha beta is a variant from the min-max. Then coming after the alpha beta, we have the depth limited min-max. And then at a given point of the depth limited, once I'm done with the depth, I can also at a given level introduce an evaluation function, which is going to have its own like mathematical equations and somehow to compute the probability of that someone is winning as compared to the other one who is going to lose. So these all are variants. I am adding each time to the algorithm in order to improve its performance. Did I answer to your questions there? Okay, that's great. Then any other questions?
The value of depth limit is based on the evaluation function, or at the initial point we take the value of depth limit, right?
Yes.
And like example, we take like 10. If in case there is a possibility that no one is winning at that point of time, and what it will do, like it will increase its depth limit, or it will just give a no solution.
If no one is going to win, then it's kind of eliminating that branch, and we are going to means we're having indicators at this time. Okay, and at this point, even you may find different variants of the algorithm, different like people introducing different concepts, but it could be like one of these possibilities. Yeah. Did I answer your question? That's great. Yes. Okay then. So I think that you guys owe me like 10 minutes. All the time I'm taking more 10 minutes. So this time we are going to finish early. And something else, whenever you feel tired, just let me know, because if it's up to me, I won't stop. But I am open if you need to take some rest or something. I will try to do that. So let's think of like after 1 hour, we can take some rest or 30 minutes. Okay, just let me know. You stop. If you will not stop, just we will leave it. Okay, so we are done with the first part. Now we are going to move to another thing. Always I'm coming with this like screenshot or this video, if you remember. So can you tell me what is this?
Representation of yourself.
Yeah. So I don't know, somewhere I have seen some posts where at the final exam, the professor is given like to check his picture among many other professors to just recognize those students who are attending his class and those who are not attending his class. So here it's the same. I keep my face everywhere. I don't want anyone to tell like this is Rania. Okay, my name is Rania. So this is not Rania. This is a representation of Rania. So here we are going deeper in AI and we are going deeper in modeling the world. So if any of you will see the picture of someone else and think that that is the person, it's not wrong. It is a representation of that person. And this will take us to the second part of this like chapter, which is going to be about knowledge and representations. So when we say representation, that is the appearance of the object in its absence. So when I made this video for you, I was not physically with you in the US. This is why I was using a representation of mine that was saying something. And this is not even like a real representation, it's an AI generated one. So here I believe that the idea is clear. Between the reality to the representation, there is a path that we can go through, and we are trying to explore this very long path. Is that clear? So first of all, so we are going to deal with the knowledge representation and uncertainty modeling. So keep us from the second part. We are going to focus with the knowledge representation. So what I would start with is like that representation of me. So, but here there is a very famous piece of art. This is like very famous. So what you can see here is just what you see. What is it?
I don't know what it's called. I just don't know what it is called.
What is it?
It's a pie.
A part. But this is not a part. So this famous piece of art is mentioned in French. Ceci n'est pas une pipe means this is not a pipe, which is representing the image or the representation of a real world pipe. Even it looks really like very close to the reality, but it's famous with this like sentence here or proposition saying that this is not a real one. Okay? We find the English version of this coming with this like painting of the apple and saying this is not an apple. Okay, so it's really deep and it's really nice if you really focus with this, because if this was an apple, what could we do? We can divide it and eat it right now. But this is not an apple, it's a representation of an apple. So here we try to explore things from the beginning, where humans started to represent things using arts, using painting, drawing things. So another way to represent, we do not only represent things from the real world, something that I can see, a chair or whatever, or a table. I can even represent abstract things. When I talk about abstraction, that are things that are untouchable, things that are coming in my like imagination, in my brain. If I tell you about, you may have a different representation of the same thing. If, for example, now I may ask you guys, we have 3 in the class here today. I may ask each of you to draw a flower for me, for example. So I will be having different representation of a flower. one like this, maybe I don't know the other one how it's going to look like. So we will have different representations of the same thing. At the end, this is a flower. And we started with painting because it's like before even computers were there, before everything, like this is a very basic example. So to express his love, a baby or a kid can give this like drawing to his mother saying, I love you, mom. Or if this kid is growing a little bit more and he's turning into like college, falling in love, and he's also on the other side falling in love with the mathematics. So somehow to express his love to his girlfriend, if she's also crazy and she loves mathematics and will understand him for sure, he can show her this equation, like I send her this and say, try to plot. I don't know if she will see or not, or she'll do or not. But in all cases, this is another way to represent your love, is thanks to another tool different than painting, which is mathematics, which is equations. So another way is even just writing things, because writing is also a powerful tool. So here I can say I love you to say I love you guys. So it's all different ways to express the same thing. What are we trying to do here is modeling, representing things. Yes. So here we are representing things in different ways, which is a little bit complicated at this level to a computer to understand. And when we're talking about computer and computer science, and you guys are here in my class today, you may be having plans of finishing a PhD for sure. Some of you at least. So if you are planning to do so, or even for your master thesis, because I know some of you may opt to have some like project, and that projects may be quite similar to what you may have in a PhD. So in this project, what you are going to have, or what is a PhD?
Research.
Yeah, doing research. What is research?
Modeling.
Modeling what?
Some idea, some new ideas.
If just an idea, so I can say, who is going to model this chair and I will give him PhD. It's not like that. She will model this like
in different ways.
why you are going to model this? To solve a problem. So it's all about problem solving. So I'm tired and I need to sit, and I need some virtual chair, for example, to sit. So you try to find a problem, and this is the hardest thing in a PhD, because what you do in the start is that you are going to go back to the literature review, you are going to see what others did, and you are going to have a whole idea about the topic you are going to work in. Then you are going to find some problem. Some points that are like not treated before, some points that are treated with some limitations, like we were seeing with the algorithm. You're coming up with a new idea, and so this is a PhD. And once now you are having a problem, what are you going to be modeling? Is that problem. So if you are coming to this point, then you are going to get your PhD. So the problem of modeling here, it needs special tools to be solved or to be represented first. So we need to represent. If one of you, for example, works in the, let me say, medical field, and we are having the problem of skin cancer classification. First of all, I need to represent the lesions. I need to have some representation, and that is the way I'm going to deal with, because I don't really deal with the real world like lesions to have real world people, because I'm implementing things within a computer, and this is why it's all about programming. So what we are going to program is the solution for any problem. One of the tools, or I'm going to say the powerful tools, is the machine learning. Machine learning is just a tool for representing a problem. So for this tool, what we have here, we have 4 main points. The first one is that machine learning is based on capturing patterns. When we talk about patterns, it means that we are going to extract common patterns that are like somehow repeating each time. From that patterns, we are going to execute algorithms, machine learning algorithms, for example. So this represents the complex relationship between relationships and structures that are often difficult to model using traditional methods. So each time there was a method introduced, it's just because previous methods were not enough to solve that. Further, we are going to go through machine learning problems, and we are going to understand where exactly it is coming. Also, another, like, this tool allows data representation, and here, how we represent things in machine learning. So there are mainly like 3 to 4 points. The first one, we are going to work on feature extraction. When I say feature extraction, it means that given my data, I am going to extract pattern or feature or some indicators that are going to help me solve the problem. The problem may be classification problem, regression problem, or any of the machine learning problems that we will see next. So let's take an example of feature extraction. If I have, in the case, for example, of natural language processing, let's see. Natural language processing deals with
Audio files.
yeah. So we have propositions, we have sentences. For example, if someone wants to show love, it's going to say that sentence we already seen, I love you. So in this sentence, what is the most important feature that is reflecting the whole context? It's the verb to love. Yeah. And in this case, this is the feature that I'm extracting in order to understand the whole thing. Okay? So, given another example, what we have, the dimensionality reduction. Here, for example, if I have my data, and if you guys remember in the first class, I was showing the example of shadow of my hands. I said this is a representation of a hand. You can see it from here, so it's like a first representation. You can see it this way in some other representation. In order to find the best angle from where you see your problem, this is itself deals with data representation, which is existing in the powerful tool of machine learning. Also, we have the embeddings. This is an example for embeddings, and that is it. So we have also the function approximation, which is now more, here we are dealing with data, whatever our data is. So if we are saying, given the example of visualization, we're having a computer vision problem. We are dealing with image, for example, the presentation of a hand. If you are having this, so you are dealing with an NLP context, natural language context. So it depends on your context, so you will find your data. The data, it varies from, for example, you are in the field of medicine, you may have different data from, I don't know, education, for example, or pictures of schools are different from pictures of skin cancer, or any other examples. So once we are done with data here, it's first set. Now we will be thinking also about the mathematical approximation that we may have. So another advanced level in machine learning is when we talk about the function approximation. And here we talk about the neural networks, because neural networks, they are learning from data. So from data, they are going to find some approximation for unknown function or systems based on this data. And so they help represent the underlying structure of the problem without requiring explicit rules, okay? So why I'm starting with this example or motivation? Because I don't want that the AA class may seem a little bit boring. These are the advanced elements, but as I was saying, in order, for example, I have my, here, I have this thing, which is in the real world, okay? And I want to go to the representation of that thing, which is the function, for example, that is going to take me to this representation. So having this function that is going to, this is my x, I'm going to finally find the image of x, so the function of x here. This path is what we are going to explore. It's impossible to explore it all in the AA class, to be honest with you, because there are other classes. I don't know how it happens at UM Flint. There will be logic classes. In the logics, there are different mathematical, but I am going to try to cover most of it to make the picture as clear as I can. So In machine learning, we have the decision making. And here, when we talk about the decision making, now we are done with the representation. Decision itself is a representation. So we represent, you are successfully representing this thing. If I'm checking your representation, I'm saying this is the chair, the representation of the chair. You did it perfectly. So here you are successful. So here I can say I sit or I don't sit. And this matters more than your representation. So if I have data or I have representation or I have this, I'm coming to this point, it's not enough to have data. Because if I have data, is there any information if you guys have only data? Data is give me an example.
Any type of data.
Any type of data.
Image.
Let's say this, I don't know.
So one of my favorite examples is like just a bunch of numbers in a database. It could be phone numbers, it could be social security numbers, it could be student IDs or anything like that. If you don't have any context, then there's nothing really that you can do with it.
Yeah, so let's consider this number. I don't know, 1, 2, 3, 4, 5, 6. Do not have any problems. So this is a number. So if you see 1, 2, 3, 4, 5, 6, what does it mean for you? What is this? This is nothing. There is no information that I can take from this. This is just numerical values I may consider. If it's stored within a CSV file, it's just data in a CSV file. It has no meaning. It has no value. I cannot interpret. The power of AI or machine learning is to turn this data into information first. Because if you have data, this number, for example, I can give it in the card. I can distribute physical real cards in which this number is. Still, this is not within my computer. Still, AI can do nothing. So if I have this representation of this number, so I have the information. The information may have some meaning. For example, I have a folder. It's called phone numbers. There is a context. In this folder, I'm having this 1, 2, 3, 4, 5, 6 number. So here, it's not data. Here, it's information. So I have information, somehow the meaning of this. So the idea is to turn data into information. Now I have information. This 1, 2, 3, 4, 5, 6 number that Jeremy is suggesting is a phone number. So, and let's say we have in like CSV file having multiple. It's not the only phone number. And at this point, I have like key value. I know it's labeled. We will deal with the supervised data later. But what I know this phone number means, for example, something for me, which is the number of, for example, the Department of Public Safety, DPS, here. And me, I've just lost my air card. And I was stuck. I'm not able to open this door. So if I have this number, I know it's the number of DFS. It's not just an information. It's a extremely useful information. So the power is to turn this information into decision. When I was stuck there in the door, Farah was opening for me. But if you seen I was opening my phone, checking the number of the DPS, I was going to take an action because it's that information is already there. It's not 1, 2, 3, 4, 5, 6 anymore. It's something that has a meaning that I can take it into that action. So here I can take a decision based on that. If I'm taking decision, this is the power of computer science. This is the power of your PhD if you are doing so. If from your PhD, we are moving from abstraction, data that has no meaning, turning that into insights, and from that insight into like decisions, that is the power of your work, and that is your contribution to the world. Okay? So here, the decision making is through classification, for example, because here we are dealing with problems that are addressed with machine learning. So machine learning is a powerful tool, yes, but it does not solve all the problems of the world. This we need to understand and keep in mind. Among the problems, for example, classification, regression, clustering, and other machine learning tasks, here the machine learning shows you how to represent your decision, okay? And we are going to go through all this. And I may also need to open some parentheses at this level. I know that some of you are taking a machine learning class. Okay, I know you're taking. How many are taking? Yeah. So what I hate the most is that I keep teaching and no one stops me. You know this. I think now you are getting to know me very well. So if you guys feel that in the other machine learning course, you are like not understanding something or you are mainly focusing on something more than another thing, you just let me do, because at some point, it's not my mistake. This AI course and the machine learning course have common points. So I will do my best to avoid repetition at that part. So I will show you things in a different way, okay? We will reach at that level still after the first exam, which may be taking place next week or the week after. I'm going to announce that via the announcements in the campus.
Oh,
So-
I do have a question about that. Sorry.
Yeah.
So for us online people, how are we gonna take the exam?
So don't worry about that because it will be for sure online.
Okay, awesome. Thank you.
So I may give you some time to solve that and it will be online, no worries. And if I'm making it online for these who are like online, I always want to be fair with everyone. So the exam will be for everyone online. The only thing that those who are like coming in person, just you need to bring your laptops and come, and I will treat you exactly like those who are online. So it will be. So where are we reaching now? So we are turning data into information into insights or decisions from that. So this is the what we need to do as like computer scientists or whatever. Now, we are in the context of knowledge representation. And when we say knowledge, it's like things from the real world. This is what we know about the world. This is what we are trying to solve problems that are related to this world, at least. This is what we can do, okay? So in order to solve such problems, and thanks to computer science, and this is what's really happening, there is a timeline that represents from the start to enter today or the coming to the point of the real world. So what is really happening at this level? We are having a set of logics. I may give you a few seconds to check or go through these logics. So the first one is, it's mentioned there. Someone helps me to read it.
Classical.
Yeah, what can that mean for you? It's a logic, which is the very, very basic one, which is the very first one, which is the classical logic. So here we are going to go through the evolution of these logics. The evolution of logics is now that we are having a machine, and always keep in mind that this machine, it's not this machine we are having right today. So in the start, we had a machine with a very limited like performance, abilities. You would consider that factor as well, okay? So now someone is there and he wants to model this world and started by thinking, and I will let you think. How could we model this world? In the very, very basics, like what does that mean for you, for example, classical logics? To insert knowledge, for sure, keep in mind that you need to insert your knowledge into this machine. Yes?
Trying to model some basic rules to the machine by entering some numbers because machines understands.
At this level, it's not even rules, because when we talk about rules, it's more advanced. What your machine understands in the start, what you ever taught, learned about machines?
Binary.
Yes?
Would classical logic just be like true and false, like validity of a statement?
You are right. So here what we have is the very basic knowledge that we know if something is true or false. If I have some like statement or proposition, I can deny that or accept that. There is nothing else. For example, what I can say, I say something which is true or false. This is a boring class.
All puppies are cute. There we go.
So another example. So something that takes the value 0 or 1. There is nothing else in the middle. Like, for example, if it's raining, what will happen? The ground is wet, for example. If it's raining is true. Means it must be wet, the ground. There is no other option. Is there a way that the ground is wet and it's not raining? Given this context, no, it cannot happen. If it's raining, there is nothing else to consider that the ground is wet. If the ground is wet, it means just it was obligatory, like raining. So here we have, it's binary, raining, wet, not raining, not wet. Is that clear? So the first time we started representing things, we were using the binary like 0 and 1, or true or false, and this is the classical logics. And next, what we have? Propositional logic. I want you to read things so you memorize that. Because if I will read, I will keep, you will not remember that. You can say it again. And it's coming from the word proposition. And when we say proposition, means sentence or some affirmation, or like I'm saying something. If, for example, I'm saying it's raining. It's raining. You can say not raining. False. You can also say, yeah, you're right, it's raining. But there is a difference between both, okay? First, it's whether 0, whether it's raining and it's wet, there is no other option at the same time. Or it's like not raining means it's not wet and there is no other, like if, for example, this actually has been inspired from the philosophy, and I don't want to make it philosophy class, but in the real world, when we started understanding what was happening, first time we understood like the day and night. So what we know is that if it's dark, then we are at night. If it's not dark, then it's daytime, okay? So there is no in between. I cannot say, oh, this is the lunch time, this is I don't know which time, or this is 4, this is 5. No, day or night means black or white. There is no other degrees, okay? Then what we say, I can say something and you can tell me if this is true or this is not true, okay? I can give you, it's not how to, a proposition. So my computer could understand the proposition. This is why it's called propositional logic. I can insert any proposition and it can tell me if that's true or false, okay? Next, what we have,
First order.
Which is? Which is a little bit more advanced, if you can see that. So how we can get more advanced? So in the start, we are talking about yes or no, black and white, day or night. Then we are giving some proposition, and then we are saying that could be true, that could be false. First order logic, yes, Zoya?
Is it starting to like quantify things now?
You are right. So in the start, we are just representing things, and then we quantify things. When we quantify things, it's like using what we call them linguistic variables. Keep that in mind. Because what we are doing, actually, we are going towards the real world. The real world means what? It's a representation with a very, very, very high dimensions. Dimensions, if I am here, it's the dimension. It's just 2. This is what we call binary. So I'm going from the 2 like dimension, bidimensional space, towards here we have an infinite, let me say, or a very high like dimensional real world. So here we are increasing the dimensions. So when we say that we are moving from classical logic to the real world, means how to approach this real world. It's like, for example, Ayub likes my class. I'm sure. But it's not enough, true or false, I don't care. I must like my class. Now I want that everyone likes my class. So from once a proposition which could be true, could be false, here I am quantifying with numbers, okay? Like I'm introducing things like everyone, okay? And here, if, for example, we have the linguistic variables, it's for all, and there exists. And you guys, I'm sure you are familiar with the mathematical representation. So this is for all who are loving my class. I love you. And then there exists for sure someone, he's not liking my class, and he must show up and say what he is not liking so we can fix it together. Yep. So is that clear? Online?
Yeah, that makes sense.
Great. After the first order logic now, after starting introducing quantifiers, like Zoe is saying, we have the many valued logic, which means we are always more near to the real world. We must keep this in mind. So with the first logic, it's 0 or 1. The second one, I'm giving a proposition and we are deciding whether that is true or false. Then we are started introducing for all or there exists like quantifiers. And now in the many valued logic, we are representing things that may take, as the name is mentioning, many values. For example, 0 or 1, they are just 2 values. Many values is like, for example, many values. You can give me an example from the real world. So if you are taking the traffic like light, what we have, what values that could be taken? I have not only 1 or 2 values. I can have set here, I'm just giving 3 examples. It could be red. It's not 0 or 1. It means something. It means red. Or it could be, for example, orange, or it could be green, sorry. Yeah. So this is my interval. These are my multi or many values. Okay. So this is the many valued logic, and then we start now some philosophy in this like concept. It's like anyone that can be guessing what is this? Epistemic logic. We are humans, okay? We are approaching to the real world. And
so
in
this
the
is starting to get to like fuzzy beliefs and opinions?
Yeah. It means like it's not raining, but Ayub knows that Farah believes that it's raining. You know, so the more we are introducing like what we call them, linguistic variables, keep it in mind, the more we are approaching to the real world, and the more that we are increasing the dimensions. Okay, so what is the best like the dreams world? Is that I have that infinite dimensions that I'm representing everything. Okay, but we are stopping in 2000 in the fuzzy logics. Anyone is hearing about this?
Yeah, I've heard about it, but I never understood it.
Is that where there's like multiple truths or falses for one statement or something?
Okay, I'll make it very simple. But okay, I don't want to engage you with my class because I know you guys may be very busy and I understand that. But I would appreciate it. Means just extra points. Okay, I have this extra point side. For those interested, or if you want really to understand physiology, only one student. Each time there will be some challenge, only one student may give time for that. If one of you may present like presentation about fuzzy logics, it would be appreciated. A quick one, like 30 minutes presentation. We may discuss that after the exam, not now. Just send me an email, say that I'm ready to like understand fuzzy logics with you, and we can go for it. Okay. But this is I will not go until someone will present. I will do it by myself first. So when you say fuzzy logics, at least I want my students to be distinguished from others, because it's not everyone that you talk about fuzzy logics that you have the exact definition of that. If you're understanding this, means you are very close to the reality. So this logic announced or officially like is there in 2000. By one like scientist or researcher, it's called Lotfi Zada. And so this one was introducing it, let's say discovering it, because it was existing before in the Second War, and it was there already. But some things are there all the time, but not published, but not like, so let's say it's in 2000 discovered this logic. The idea behind this logic, when we say it's fuzzy, it means what? It's not clear, it's unclear, okay? So when it comes to, for example, classical logic, it's 0 or 1. I know it's day or night. There is no in between, as I'm mentioning. In the case of fuzzy logic, in this room, for example, it's cold. I'm feeling cold. Someone else will say, no, it's hot. We are binary. If you are saying it's hot, I'm saying it's cold. We're just still in the very first step. But if Farah from the other side will say, no, actually, it's not that much like cold, but it's 70% cold. So we are not confirming that it's cold. We are not also saying that it's not cold. It's cold with a 70% percentage, which means that 30% the room is hot still. So you are at the same time like confirming the two given propositions with a given probability. So this is the fuzzy logics. So from that, we are inserted into computer 0-1 binary values towards giving him this knowledge about the uncertainty of the word, because sometimes I'm feeling it's cold, I'm not sure, but there is an exact value that shows how cold is it. So if we are at this level, we are at the fuzzy logics. And like always, if something is introduced to the word, everyone is trying to see that concept from his own perspective. So you will see whatever machine learning algorithm you may like see later, you can see the fuzzy like version of that algorithm. Okay, so for example, if I have, I would say like whatever I have. Are you guys familiar with the machine learning, or will we keep it at that time?
Yeah.
So
Sort
if at some point I'm talking about something you are not understanding, just say to me, stop there, hey there, because I want to teach you everything. But it's your right to stop me, because some things we can come later to understand. So I will say, I will not talk about machine learning. I will talk about classification, which is a problem. And if I have a classification problem, I think that everyone knows that. I have my space, and I have some limits, which is dividing my space into two subspaces. The first one saying that this is like loving, let's say, loving my course, represented by hearts. And some others, they are like, I'm happy with the course. Let's say they're just, okay. Someone is coming now, and whether it's going to be with those who are happy with my class or those who are unhappy. So this is what? This is binary. It means you don't have the right to be sometimes happy and sometimes unhappy. You don't have the right, if I am deciding you are at this side, you must be always loving my course, which is not the case. If I'm deciding that you are at this like side, which is giving you the right to always stay at that side. So here, if we are talking about the fuzzy classification, means we are not only thinking of this as like a wall, that is, there is other like ways to introduce it. Is that clear?
Yeah, that makes sense.
Okay, great. So is it the time for taking some rest, or I keep working? No one is telling me. I think, yeah. Yes. We can take 5 minutes rest. And then we come back after 5 minutes, okay?
So are you gonna just randomly pick a student to do the presentation on fuzzy logic, or is it like?
Yeah, you want to confirm that now?
Sure.
Yeah, okay, then everyone knows that Joy is taking the fuzzy logic presentation. So. Great. Okay, so I will send you a separate email to work on that together.
Yeah, that'll work out. Do you have like a due date, do you think?
What?
Do you have a due date that you want that done by? You said after the exam?
No worries. No, first to finish the exam, and then we will
Okay.
talk about that. Yeah,
Phew.
because as you can see here, it's the very like advanced level of logics that we are discussing now.
Yeah.
What we will do now next, after we are going to start with the very first one. So we
Oh,
are
okay.
going only to because we cannot go through all this. At least we are going to go through the propositional logic and the first order logic. Once we will be done with this, and after the exam, we may take a look on fuzzy logic. Okay?
Okay, makes sense. Thank you.
Welcome. If I say 5 minutes, it can take 5 hours. You don't tell me the 5 minutes are done. Same as the class. So everyone online is here?
Yep.
Okay. So now, as I was mentioning, we are going to start with the first like basic like logics that we were seeing for now. And in general, if we want to talk about AI, we were introducing like terms like agent and environment. For now, we are already familiar with this. We know very well that when it comes to agents, so when it came to agents, so we were not only like talking about the representation, there is a whole axis that deals with design of agent, because when your agent is a robot, it's different than when your agent is like the computer playing the game. So here we talk about the agent design, which goes or varies from the reflex to the goal-based, utility-based. And for the environment, we were also introducing the different types of environments, if you remember that table in the start, varying from the deterministic or fully observable environment, that I know everything about my environment, to the stochastic or partial observer, that some points I don't know. It introduces uncertainty at some points, okay? So these two axes are okay. Now what we are going to deal with, which is going to give like birth to the design space of AI, which is the knowledge representation axis. So we are going to focus like on this one, and it varies also from variables, let's say words, could be linguistic variables, like I'm just saying, towards the logic, which represents the meaning or the semantic of things. So this is the whole AI design space, and we are going to start with the knowledge-based agent to understand, because there is a difference between the definition of agent that we've seen so far. What is an agent?
It's the one who's gonna take the action.
So the entity that is that
Taking action on the environment.
blindly taking action, perceives its environment
Yeah.
thanks to sensors, and
Activate, yes.
actuators, thanks to that, it takes actions. Okay, so this is a very basic one, but now it's not just an agent, it's a knowledge-based, so it's a different level. So with this introduces the knowledge-based. In this course, it's going to be denoted by KB, and for knowledge-based. And when we talk about the knowledge base, that stores knowledge, which is represented by sentences in a particular knowledge representation language, whatever, but that represents the sentence, okay, whatever the language. For sure, we will take the example, it's training, it's English, okay? And we have not only the knowledge base is interacting with the inference engine thanks to the agent. So the inference engine here draws conclusions in new sentences to answer questions, solve problems, or suggest actions to perform or to achieve a given goal, okay? So now is that clear? We are moving from the abstract definition of an agent towards a definition which is motivated with knowledge base and inference engine, okay? So in all cases, it's not enough to have data, to have information. We need to always turn data into information into insights, to take decisions, to interact with the world, to solve problems, which is one form of that is like having queries and conclusions given that queries, okay? Interaction, okay? So knowledge representation language now introduces sentences and facts. When we say sentences, means propositions, and we have the representation and the environment here. So we need to introduce some syntax that defines the sentences in a language. If, for example, what kind of syntax could be defining a language? Subject, verb, adjective, I don't know what. So it depends on the language rules, okay? And then we have the semantics. The syntax is clear. So sometimes you need to write a sentence and there is no syntactic mistakes. Next, we can interpret that to understand the meaning of that, or the semantic that defines the meaning of the sentence. Like, for example, define truth of a sentence in the word, okay? Then we have the logical inference, which is the deduction that derives new sentences in the language from existing ones. Like, for example, if I say, I'm happy, it will make someone else happy. It's automatic, okay? It's like this. So we start with the very first logics, the first one, propositional logic, like I was saying right now, and the first order logic. Today we start with the propositional logic. I don't think we're going to finish all, but at least we'll go through the basics, okay? So the basics of how to present a propositional logic. What is the syntax for this? So if I have a sentence saying, I'm happy, this is an affirmation, this is the proposition that I can give it a symbol, for example, P. You are happy is another affirmation, it's another proposition that I can denote with Q, okay? And this syntax is not only if I'm talking about Q or P or any other letter. This is just atomic. So just I'm talking about only one proposition. Otherwise, as the word is more complex, in order to represent things and sentences from the real world, we need a combination of these all atomic samples. So what we can have, we can construct our own logical presentation thanks to first parentheses. Like here, I can set it or group it into different groups or clusters. And also I have the logical connectives that are connecting one proposition to the other, okay? So we will start understanding this. But first, just let me know if you guys have I will not ask if you have background. Any of you don't have background about this, symbols or this syntax? Like someone who never seen this and or this table, let me say. Are you familiar with this?
Uh-huh.
Who?
Oh, sorry, I am familiar with it.
Great. So we start running. Someone is not familiar, you can send me an email, you can come to my office, we can discuss that. But if you are familiar, we will not waste time. So we have the different existing logical connectives. We have the negation for saying not P means the opposite of P. We have the conjunction for connecting P and Q. I am happy and you are happy. It's both happening at the same time. And the disjunction, P or Q, at least if you are happy, then all okay. So the implication, so here we have P implies Q. It's like the reason and the result, okay? And the P conditional, which is mainly the implication in both sides. If I have P implies Q and Q implies P, so it's bi-directional. Okay, bi-conditional. Now we have the truth table here for all these different elements. P and Q can have what values? True or false? And we'll have the combination. So we have two elements. How many? Four combinations. So P is true and Q is, P is false, Q is false. So if I have P is false, the opposite of false is true. So the non-P is true. P and Q both are false means is false. And if the or, at least one is false, and both are false, already false. And the implication, false implies false. Yes, that's true. And the B conditional, that also gives true. Are you familiar with this? Okay, then. We have then the false true, true false, and true true. Okay, I will test if you are familiar with this or not. Don't worry. So what we have now is a quiz. Once done from the quiz, you can leave. You don't wait for me to say we are done. I'm not sure if this quiz is published in the classroom or I'm still not making it visible for everyone. Please, if you can check, or I will check first. So what we will do in this quiz, we are going to try to fill this table with the right answer.
I don't see it.
Okay, the module itself is not published. So,
And by the way, your
Yeah.
example from earlier was very mean because you had P as I'm happy and Q as you're happy. And then your little example was you or I are happy. You are not happy, therefore I am happy. And that's just not nice.
Oh, sorry. I was expecting that in a different way. You may feel unhappy because you may think that I'm like the time is there and I'm still not finishing and this is the on, but at least because I'm explaining to you that I'm happy. And you may see this later and you will be okay, then I'm happy.
We'll see.
So, yeah. So I think now the quiz is there for everyone.
It's there for.
Okay, so try to answer the semantics quiz 1. So how it's going to be to work? I am adding this quiz and I am giving like this empty space. You are going just to evaluate this each time and you are going to mention if it's true or false. So just to test that. That is it for today. You can try to do that even with a pen and paper.
And wait a minute.
Okay. Oh. Jeremy, I didn't ask if you are okay with the fuzzy logics and you're understanding that or not.
I don't know. I've run across it before and it just, I guess I just haven't seen any examples of it that I can really sort of
But at
cling
least
to.
if I ask what is a fuzzy logic, you can tell me what is it at least.
I don't know. I guess if you look at, here's my understanding. I could be totally wrong. So you had your little graph with the separating happy and unhappy students. If there was a group of students that sort of went across that line, a circle that was somewhat in happy and somewhat in sad, and there were a bunch of students in there, you couldn't say that that group is happy or that that group is sad. It's kind of in between in that way. And if that's just totally wrong, I'm okay, and I'll just approach it from a different way.
No. Actually, this is just an example of a more advanced example of a given machine learning or application of the fuzzy in machine learning specific algorithm. So this is not what I wanted to stay in your mind if I ask about fuzzy logic. If I ask about fuzzy logic, I want you to keep in mind that it's not binary, it's not dark or like light, it's not black or white, It's not day or night. You would say that it's like percentage. It's a given probability value. It could be
Okay.
like because okay, we are at the start of the day, okay, 6 a.m. 6 a.m. is not night, and it's not the like sun in the just middle of the sky. So you can say it's 20% day and let's say 80% night. It's not cold or hot as I was mentioning. It's 70% cold, 30% hot. It's not like white. It's not black. It's 80% like 50-50. It's a gray color. It's introducing a new variable. This is a fuzzy logic. But applications vary, and you can see it in different ways. Different scientists, different people are discussing this, so you can see many things. But always, whenever you see, you keep in mind that fuzzy logic is based on like belonging, probability of belonging, okay? It's not you belong or you do not belong. Okay, I belong, but not 100%. With a given probability, I am that, but with a given probability, I am not.
Could I think of it as like similarities overlapping?
You can think of that. You can think, and this is what I was saying. We will introduce something, and you may find many people thinking like that. You may be the first person introducing a thinking like that. But you need to stick with the very basic definition. So if now I will ask you, Jeremy, what is fuzzy logic? What would be your answer?
Let's see, it's not day or night. It's like probability and it's gray.
That is
Good.
good job. This is what I want to hear from you. With
right.
this in mind, believe me, whatever version of the fuzzy logic that you will be like facing, you will be like understanding how this problem was approaching given this solid like definition.
Okay.
Okay, so yep. Any questions?
Yeah, I tried to implement the tic-tac-toe. I don't think I got to the point where I could call it like an A-star algorithm or whatever, but I made a little C# program that had a node class and a state class, and I started populating my tree and decided to like count how many different states it went through and how many were won by O and X or whatever. And those numbers did not make sense at all, and I don't know why. But when I started thinking about how I would try to make it play against me, I didn't quite understand early on, like high up in the trees, closer to the root, how it would decide which way to go based on the winner and loser lower down. Like if it gets really close to the end, it can make one move and become a winner. But just thinking about it, I wasn't sure how to have that bubble up, and once I make a move, how it's going to decide which way to go based on those eventual results. So I don't know if there was any way you could like help me figure
Yeah,
that
sure.
out or understand it quickly.
Yeah, sure. So for me, first, I want to appreciate that you are going like far and you're trying to implement, and that's really good. So the thing now, if you're implementing, it depends. So I just want to ask you a very simple question. Are you trying to implement it by yourself from scratch, or did you find some code available? Because I know there are plenty of codes like in GitHub or in the net that you are not understanding.
Well, I first tried it by myself, and I had to get a little help with the recursion, and that sort of shrunk my code down quite a bit. Before I did that, it was just like for loops, just down and down and
Yeah,
down.
this is
And
what I needed to understand. So
yeah,
if you are writing from scratch, so first of all, if you may find codes in the net, so there is a high like probability that that code is not executing or there's something wrong because everyone can publish their own codes, okay? So in this case, I will be sure checking with you from which source you are getting this code, and we can try to execute, we try to find based on the README and so on, if there are any problems. If you are implementing it by yourself, then here we can only get back to the class like lecture on which we were based, and we try to check if things are matching or not. So I believe that we can have a separate meeting, or we can make it like, if you want, work on this as a little like project presentation,
Sure.
so that everyone can share, and everyone, you can, for example, present, share your screen, and we can try to see how, if we try to solve it first, and we present an executable version of this algorithm.
Okay.
Okay.
But even theoretically, how it decides early on what to do, I just didn't understand it.
You said that you were implementing one of the like loop, like the for, this is what you were mentioning. So you have doubts that maybe one of the instructions or one of the lines is not supposed to be in the right place, right? So this is what I agree we need to check. So we try to first check the whole code, and then we try to execute one part by part, and then it's like that we try to fix things.
Oh, well, that's how to fix it, but like what I have is results at the bottom of my tree that I don't know how theoretically like an algorithm will understand how to get there from an earlier node. Because I know in our min-max, you have just the very simple 2 or 3 levels where it takes the minimum of those 3 and then moves it up. But if the numbers are like, 8 layers deep and they're just 0, 1, and -1, I don't know. I can't even imagine how some information about that could get up to the top.
Sorry, the min-max, it's not like that, Jeremy. The min-max is not only like 2 layers. The min-max, it can, we were already saying that it's not like, it's, you have min-max, 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 unlimited depth you can have. It's not like because you have 0, 1, 2 utility, -1 or 0 or 1 utility values that you have only 3 levels. It's not that. The levels of the tree, it depends on how many times are you going to play. It's my turn, then it's your turn, it's my turn, it's your turn. So it's one time the min turn, it's the one next time is the max turn. So it's like this. And the min max do not have like limited depth. No, this is just the example we're seeing like in the class. But we were mentioning that it can go further, and this is why one of the variants is the depth limited. So we can limit the depth of the min-max algorithm. This is what we were just discussing in the start of this class. So here, this is why we need to focus what algorithm you are planning to implement. If, for example, what version, because you are thinking sometimes you're implementing the min-max with only 3 like elements, means you are limiting the depth to 3. If you are limiting the depth, so it's not the min-max, it's the depth limited version of the min-max. And here, this may also include that you are in somewhere in your code, you could be using an evaluation function. It's based on this evaluation function that you are checking the different nodes. So here, first thing I always say when we are coding, print everything. You see that for I in like 1 to 10, print I, please. Because when you see things, you can figure out your problem. You try to do it, and if not, you can share with me that code, and we can have a meeting to fix it together, and next you can present it to your friends.
Okay.
So, did I answer your question?
Maybe. It's if you go back to your 3 depth min-max. So I've got 8 levels for mine, but I guess maybe I need to take the max that slices it this way, and for each level, the algorithm will pick a node. So I'll just give you an example. It says 4, 5, 6, and then 3, 8. So we're to 3rd level, right? That could be at some point a 0, a -1, a 1, a 0, and a 1. What would max select from that if there's ties and there's ones that go across and wins and things like that if I'm trying to make something that will play tic-tac-toe? That's what I'm trying to imagine is how I'm supposed to get that information up the tree for min and max to pick on an early node. Maybe I'm not asking the question right, but
I will try to understand your question.
okay.
And let me know yeah, that's the case or not. So now your question is that, given this, for example, case, if you're having many nodes and some of them are negative values, some are one, some are like repeating, some. So your question is exactly how to pick that min or max value?
Or how the
So in order to do so, yeah, if you are asking about how to pick, this is the question, how to
well,
pick.
it's more like I only have a result when X or O wins. I don't know how to get those results back up the tree in order for the algorithm to pick which way to go.
Okay, so how to pick is the implementation of the function that you are discussing right now. So are you implementing, or maybe I believe that one of the problems you may have is is at this level. Try to double check this implementation of the function.
Yeah, I don't have this in my code at all. All I've done is
You
make a
cannot
tree.
say I'm implementing the min max and I'm not having some function that checks if a given value is a min or not. So how you are selecting from the given points?
Right now, I'm not selecting it because I don't have the information that bubbles up for it to pick it.
So how you are picking them?
I'm not. That's what I'm having
Then-
trouble with.
Then you are doing something other than min max, I'm sure.
Well, all I've done right now is build the tree. It's just sort of splitting off into all the different possibilities for a tic-tac-toe match. And then when you get to the bottom, when you get a result in one of the branches, it assigns a value -1, 0, or 1. And that's where I'm at.
No, you need
Yes,
to have,
it is where
if
I'm
you are
at.
implementing kind of a black box like this, no one can help you. What we need to
Mhm.
implement is step by step the whole algorithm. We go through this function, we check if it's really returning the mean, other function that is really returning or not the max, the values to what we are doing actually. We are whether maximizing the chances for X to win, which is like utility value 1, or minimizing that to have -1 for O to win. If like max don't want min to win, just the max you choose is going to be 0, no one wins, and the same for the min. In order to minimize from 1 and 0, no one wins again. So in order to take the final decision, 0, 1, or -1, who is the winner, before reaching to this stage, which is the final stage, you need at each level to evaluate this utility value and to check if it's a min or not, if it's a max or not. So you just share with me your current version of the code as it is, even that my experience with C is I have, but I am more into Python now. So you share with me as it is. I will try to check that. We can have a meeting and we can come up with next time, or next week in the review session with executable version of this code.
Okay, that sounds fun.
Okay, just don't forget to share with me, please, the code.
Okay.
As it is.
Yep.
Okay, thank you.
Thanks. All right, bye.
So I think that we are done on time. Okay, so bye-bye.